Okay, Jingjie, you should see my mirror screen right now.
Yeah.
Okay, great. Oh, I need to share the screen with Putin also. Hold on. Yeah, Jingjie, make sure you get well enough to go for OBS.
I don't.
Try to go for that.
Hello, don't leave me hanging there.
What?
Okay, what now? One more thing. My stars.
Doesn't sick, what the hell?
You were like that when you were online. You don't look sick.
Because I just don't come. What Jinjie is not here?
Maybe he doesn't want to come.
Oh, Jinjie. Why you leave me?
What?
Better not leave me tomorrow.
Leave you tomorrow? You know,
If
I don't think I can.
I'm not coming tomorrow.
But don't worry, he is.
Recording this thing.
Yeah, I am.
Hey, you got that recording with me?
Yeah, it's in Telegram.
I need notification. What have I?
For physics.
Yeah, I don't have. Oh, there is. February 27. Last week was not February 27.
I think the date is a bit. There's some problem with the dates. Okay.
No, it's correct. You didn't send the thing at all.
Are you sure?
Yeah, you check. You never send. I super. Yeah, never see. You don't send. You go check.
Yeah, I check. Hold on. Putin is asking me to check the Telegram.
So many group chat.
Yeah, so many. Yeah. Yeah, this one.
But that's physics started on 26th of February.
That was the last time we recorded, right?
No, that was last week.
Oh, last week it wasn't recorded.
You say it was recorded.
Oh, sure.
Yeah.
Oh, okay. It is.
Internet also one. $117 subscribers.
Yeah. Okay, I think there's something wrong with the dates. This should be the correct one.
Who is that?
Should be able to see my share screen, right?
Yes, I can. Yeah, that's me.
There's you, right?
See your face. Okay,
Just I somehow cannot get the date to be set correctly. Okay, let's go back here. Okay, come, let's quickly summarize. We did ionic bonding for ionic compounds. Okay, let's go to the worksheet for today. For which Fuchin has the printed version, this one. And please try to fill in the blanks because.
In what? Words?
Yeah, words.
Why not letters?
Yeah, letters too.
Why not? Why not numbers?
So yes, guys. I think I emphasized more than enough. Ionic compound contain ionic bond.
Then covalent compounds contains covalent bond.
Yes, too easy.
Too easy.
All right, so anything with ionic bonds is an ionic compound. That one should be obvious. Oh, Jingjie, I can't see
You know the examples for ionic compounds?
Yes. It's very easy. Later I'll show you. Jingjie, please fill in your own copy because I can't see what you're doing there. And metals? What kind of bonds do metal have?
Ionic. An ion.
Ionic compound has ionic bonds.
Metal bonds.
Yes.
Legit, that direct.
Well, almost. They call them metallic bonds.
Same thing metallic bonds. So direct.
Yeah, easier.
Then covalent compound, what's the structure?
But you notice for covalent compounds, there are two kinds, number 2 and number 3.
Yeah, what's the difference?
Fuchin fill in covalent bonds for number 3 too.
Same thing.
Yeah, same thing. The difference is in the structure.
Then why is there two same things but different structure?
Later I'll tell you. But let's look at examples. Hey, come on, we've done this. Examples?
H2SO4. Oh, must be metals. That's the periodic table.
Yes, there must be a metal and non-metal inside.
Okay. Aluminium.
No, and what?
Aluminium and germanium.
Is germanium a metal or non-metal?
The non-metal. Eh?
Do you even know your staircase?
From here go down like this, right?
Yeah.
So it's a metal, what? Because it's over here.
Germanium, right?
Yeah, it's a metal.
It's a metal? So how can metal and metal? Must be metal and non-metal.
Silicon. Aluminum and silicon.
Okay, but that one won't come up for you. So
ALSI. Al2Si4.
Okay, don't anyhow BS. Tell what write down what comes up for you. This one.
Wow, aluminum very common,
Yeah.
Here is chlorine, right?
Yes, very common also.
What's the scientific name for this?
Okay, this you have to know by the way.
Aluminum chloride.
Yes, too easy. Xingjie, any other examples? Ionic compound? Xingjie? Forgot lah. Hey, Fuchin knows, no? You better know.
Yeah, periodic table with you.
Huh?
Periodic table.
I can just go online and search.
Precisely. That's the whole point of it.
Oh.
A favorite one. You better know this one. Both of you. NaCl.
Oh,
The what?
it's sodium chloride. Sodium chloride is used for what?
It's the salt you eat every day.
Oh yeah. But why is there chloride behind the sodium? Sodium without chloride is it still salt?
No.
Then?
It's a metal.
Really?
It's
Everything on the left hand side is metal, right?
Yes.
Metal. So much metals.
Yes, a lot. 80% of metals. I think more than 80%.
90%.
Yeah.
Wait, but the lantanoids and actinoids is also metals,
all
right?
metals.
Oh, that's a lot there.
Yeah, it's a lot. And okay, but I'll give you some uncommon ones, like this one. This one is less common, but it still comes out in your paper.
Na2SO4. Na2SO. Isn't that what I asked you at the start?
Yeah, I think you asked me long ago. Sodium sulfate. Oh, you got to know the name too.
Sodium sulfate.
And the other one.
H2SO4?
No, look carefully. H2SO4. Is there any metal in H2SO4?
It's correct. Hydrogen is like at the left hand side.
Oh,
But it's
hydrogen.
group 0, right?
No.
Hey, group 1, group 1.
Hydrogen is very special. It's group 1, but it's not considered metal.
Oh.
Any metal? H2SO4?
Sulfur? No.
No, yeah.
H2S. No.
No, okay. H2SO4, put it here.
Oh.
No metals at all. Cannot be a covalent compound. All right, the other acid is HNO3.
That sounds like some disease. At the end, the bird flu or something like that.
Yeah, it does. But also totally non-metallic.
Really?
Check.
Hydrogen. Wait, so all the covalent compounds The second one has all hydrogen in it. Third one don't have. Is that the pattern?
No, it's
Oh,
something
yeah.
else. But yeah, okay. You're not too wrong. You're not too wrong. But I'll give you a few others on
Is
others.
there anything with neon inside?
Neon doesn't like to combine with other things
Oh.
because it's on the last group.
Oh yeah, group 0.
Mm.
Let's go. But then that means neon itself is already very luminescent. Right?
In the right conditions. Under the right conditions. By itself is colorless. You have to pass a current through it to make it
I thought you
luminescent.
say it doesn't like to bond with anything.
Yeah, but yeah, it doesn't like to bond.
I thought you used electricity to bond things together.
No, not for that case. You use electricity to charge it.
You sound like Jimmy Neutron, you know that very nerdy guy.
Okay, come. Let's look at the structure. Jingjie, what's the structure for ionic compounds? We have gone through last week.
Crosstalk diagram. Is it?
No, that's to represent the structure.
Actually, I forgot everything. Oh wait, no. There's that. What's the diagram called?
What's it called? Structure.
I forgot. Free
Hey,
body
sir, you
diagram.
know? So you know, I don't know.
I forgot it lah.
Giant.
Never mind.
Oh, the teeth thing.
Yeah, the big thing, 3-dimensional. Okay, Jingjie, take note, giant lattice structure.
Okay.
Because it stretches on and on and on in 3 dimensions.
Wait, the one you must draw the leaf diagram. That one is for physics, right? Yeah, physics, right?
Which leaf diagram?
The one you connect, like you draw this part and this one, they must connect and make it into what's it called? Trapezium.
Oh yeah, that was physics.
So confusing.
Look at number 2, covalent compound. What is the structure? Okay, this one. Yeah, small. Simple.
Lattice.
No, molecular structure.
Then is there a small lattice structure?
There's no small. Lattice is automatically big.
Oh. Simple lattice structure. Simple molecular compound.
Structure.
Oh.
You remember they're asking for structure.
Yeah, what's the difference between structure and compound?
Structure is how the compound fits. How is the compound bonded?
The compound is the thing itself.
Compound is just the thing, the substance. Okay, what else? What's the state at room temperature? Ionic compound. Or salt, what state is it in?
Solid.
Yes, that's all. Piece of cake, right?
But is there some at liquid?
There are.
But not in our syllabus.
Not in your syllabus.
But in your syllabus.
Yeah.
You should run MOE like you.
Next time you go and study PhD.
KPP?
PhD.
Oh, PhD.
Permanent head damage.
That's what they say, yeah. And they say max is torture to humans or something like that.
Max. Can't remember the full term. Melting point, boiling point, come.
Definite. Structured.
Higher than water.
Okay, yes, it's higher than water, but we should not just, there's no need to add in water, just say high.
Really?
That's
Okay.
fine. Can I have my pink paper to refer?
You bring home, big paper.
No, okay, next year I bring home. Next year I bring my
How
file.
come? There's a difference, right?
Yeah, next year I bring my file. Your computer is dying so fast. It went from 8% to 62%.
Yeah, because of all these things.
Oh yeah.
Okay. Density?
Wait, what's the Y minus 2 ions again? What's the Y minus 2 ions again? What does Y stand for?
Oh, just an unknown compound.
Y is just unknown compound.
Yeah.
Then Y stand got the -2 and the 4 minus thing.
We will come back to that very soon.
Okay.
Density, typically high. All right. If they don't dissolve in water, they will typically sink in water, so it's high.
So all the number one is all high.
I don't write everything high yet.
Oh. Solubility in water is low.
No, most of them are quite soluble.
But salt takes a very long time to.
Depends on what kind of salt.
The difference
Yeah, different salts have different
like
solubilities.
fine salt,
Mm-hmm.
rock salt.
Rock salt.
Oh.
Solubility in water in general, yes. In general.
High.
No, just put yes.
Yes.
Or put in add in general as well, right? Because later on you need to learn the exceptions. In this case, the exceptions are part of your syllabus. Organic solvent?
What the hell is organic solvent?
Yo, this one you better know. Example is alcohol.
Or like pure.
Something that is not water.
Oh.
Thinner, you know what's thinner?
Yeah.
Those are organic. In general, salts do not dissolve in organic solvent.
But even if it's very concentrated, it won't.
It won't.
If you put salt into a very concentrated chlorine acid, it will definitely melt or won't.
But concentrated acid is not organic solvent, no?
Really?
It's still aqueous because it contains water inside.
Oh.
Organic solvent is alcohol, thinner, acetone, nail polish remover.
I know acetone.
Yeah, those are organic.
There's
Okay.
only three.
Hmm?
Only three that's organic.
Oh no, there are thousands
Oh.
that you seldom come into contact with.
But the most common one is like those.
But at least you have to know alcohol, acetone. You
It's
have to know.
flammable, the fire gas.
What's fire gas?
You know the one with the lighter gas.
That one, yeah.
It's also organic.
Yes, that one is organic, but it's not a solvent. Because you don't use it to dissolve other things.
But they use it to like remove paint.
No. Oh, okay. There are different types also, right? What lighter are you using?
You know those handphone shop. Then they put on the cloth. Then they clean the screen.
Okay, that one is organic solvent. That one is lighter fluid. But if you buy those normal butane lighter, those click, those don't use that one. You use a different kind. I hope you know that.
Really?
Yeah.
On
I don't have a sample here, but later you go downstairs to the hardware shop. There's one yellow bottle.
yellow with the red color words, right?
Yeah. That is a gas, no, it's not a liquid.
If you make it into a liquid, then is it organic or is it still aqueous?
That is organic already. But it's hardly used as a solvent because once you spray it out, it becomes a vapor. It becomes a gas.
I can technically trap it and make it liquid.
You can, but once you release it, it will just vaporize.
There's alcohol in it.
No, there are different kinds of organic.
Oh.
Yeah.
The alcohol like evaporates very fast.
Do you know what are Zippo lighters?
I think so. Is it those scroll one?
The always you see in the movies, they tap. Wow, very nice, very cool one, right?
Scroll one.
Yeah. Those use a different fluid. Those use the kind of fluid that use handphone shop users.
Oh.
There are different kind of fluids. You have to be sure.
You put wrong fluid, then will it still work? Whoa.
It will jam out your whole thing.
Yeah.
Or you just vaporize and you can't even light up at all. But okay, that aside, okay, I will tell you what they like to ask electrical conductivity. Okay, as a solid.
Solid liquid, yes.
Cannot. Hey, you better write this down. Pushing you to.
Liquid.
But liquid for salt is considered molten. Yes. They like to ask this.
Gas
Gas is not for secondary school.
is for A-levels.
Yeah. But for dissolve,
Wow. Isn't that molten?
no. Dissolve means dissolve in water. Molten is melted.
Aren't I saying molten is also liquid?
Yeah, but it's melted. But here it will dissolve in water? Yes. I highlight. They like to ask this part.
What if it's dissolved in other things?
They cannot dissolve in other things. Remember? This one?
Oh yeah.
No.
Yeah.
Okay, what's the next question they will ask? I'll tell you the answer. How come these two are yes, or how come this is no? Go on, let me adjust the
Because
screen.
solid, the electricity cannot pass through.
So you need to write more than that. You need to write more than
But
that.
technically, I'm correct, right?
Not exactly. Come, tell me, Fujin, how are the particles arranged in a solid?
Ask the follow student. Jinjie, answer.
Yeah, in a solid, how
Yeah.
are the particles arranged?
Tightly packed together.
They are tightly packed, but
Vibrate
in an
amongst
orderly
space
manner.
position.
yes, they are more or less fixed in position. I did use the word particles, but what particles are in a salt?
Particles.
Yeah, what kind of particles?
Solid particles.
Okay, for Sec 3, you have to answer more than that. Ions. Remember your cat ions and anions?
Yeah, but isn't that's not particle, that's a process.
No, ions are particles.
Oh.
So they cannot. Jingjie write down too, they like to ask this question.
No space, I have the photo later. You gonna send a recording anyway, I don't know what's the recording.
Alamak, don't be lazy lah. You think
No space
you think you are going to watch the recording?
Actually, yes, I'm a model student, I'm an A-star student. I mean A1 student.
I thought you didn't get A. You got
I get high B, okay? Good enough already. I'm slowly getting there.
so not counted in
Ah.
until you show me the A. Oh, but we're not done. Look at molten. For molten,
Molten be like hot.
Yeah, very hot.
So if
1000.
So it's like from solid to molten. Molten is not like a liquid, it's like very super hot liquid.
Yeah. Otherwise, how do you melt salt?
Wait, molten, that's very.
That one is not melting. That one is dissolving.
But to melt actual salt, it must be a very high temperature.
Yes. You're talking about 1000 or more than 1000.
Like sand.
Oh, sand is not salt, by the way.
I know, I'm just like throwing an example up.
Yeah, sand 2000.
Then why sand tastes like salt?
Hmm?
Sometimes the sand tastes like salt.
Something wrong with your taste buds.
No, like near the sea,
Yeah.
then you scoop a handful of sand, put it in your mouth.
Because there's salt in the sand.
From where?
From the seawater.
Oh. Is the sea salty because there's a lot of pee inside?
No, because there's a lot of salt inside.
Where does salt come from?
It's from the under the sea.
Under the sea, there's Auntie Lucy.
Wait, switching right this now?
Yeah.
Because they like to ask this.
Ions are free to move about any current. Why?
Move about to carry a current.
Oh. Must we write anything else in this thing? Because I must gauge how much space I need to use.
Probably not.
I don't trust the probably not. The time you also say probably not in the end, write a shit ton of stuff.
Okay, I give you A1 paper.
No, I write it.
Oh, A3, A3.
The green one also need to write.
Hmm?
The green one need to write also, right?
Yes, yes. Green as well.
I was really. Move about. The green one is for what? For liquid, right?
Green one is for solid.
Oh, solid. Fixed. No. Wait, you must move to carry the current, man.
Yes, the ions must move.
But it's technically it's also moving, right? Because it's vibrating.
It has to move from one end to the other end.
Oh, so like blood cells like that. I mean like blood.
Yes. You know, like a wire.
Yeah.
Your electrons will move through the wire.
But wires are solid. How can they pass the current?
Because they have electrons that can move.
Oh.
Yeah.
Don't know it.
Oh, okay, no need for you to know, but he needs to know.
Hello, Jinjie.
Okay, let's go on. All right, for covalent compound, guys, I remind you, covalent compounds do not have metals pure. Okay, maybe you just to write down somewhere. Even though this is not going to be a question, but it helps you to understand. So covalent compound, only non-metals or non-metal atoms. That's how you identify covalent compound. Okay, same here. Whether it's number 2 or number 3. Okay, look at number 2. Yep, Fujin, how about this part? State at room temperature.
Liquid.
Mhm.
Solid. Liquid.
Liquid or gas.
How can it be gas?
No, look at the examples. Water is liquid, right?
Ah,
CO2?
gas.
Yeah, so liquid or gas.
Wait, does the copper 3 fall under this category?
Copper what?
Copper 3.
Copper sheet?
Copper sheet. Copper 3.
Copper 3, what's copper 3?
Marker please. What this one? The
Sure, go toilet.
Yes, go. There's no copper 3, only got copper 2.
yeah, copper 2.
Fall under what category?
This one.
Copper 2 is part of an ionic compound.
Yeah, so it's also it falls under ionic compound.
Yeah. Okay, since you mentioned it, let's add in. Huh?
Wait, it's copper 1, that's normal copper.
No, copper 1 and copper 2 are both normal copper.
Then why got 1 and 2? The bonding, right?
Come, I show you. Since you asked.
I know you can explain before, but I forgot.
Very simple. Even though this is not an official way to. This is copper, okay?
Yeah. Copper is Cu?
Yes.
I thought it's Co.
No, CO is cobalt.
Oh.
Copper is a metal, agree?
Yeah.
So does it lose or gain electrons?
It gain. Better it lose.
Yeah, you better know that. Huh? So it can either lose 1 electron,
After they will lose. Oh yeah, then we lose 1.
then to become copper plus. It can also lose 2 electrons.
After one can lose 1 because it transfer over, then it gives 1 an ion over.
It can give to 2 anions also.
But I thought the diagram can only have like one more slot or
It depends on the anion. Some anions can take 2 electrons, some anions can take 3, which we'll go into very soon.
you say very soon, but very soon like 2 weeks later.
Yeah, okay, tell you now.
Okay,
let's go. Let's go. But let's finish row number 2 first, huh?
My battery dies so fast.
Yeah, it's scary, it's scary.
Maybe it just shuts down.
Melting point, boiling point. Covalent compound.
Low.
Too easy. Density.
Low.
Of course, because it's a
If the
liquid
melting
gas.
point is low, density is also low.
Electrical
Is
conductivity.
it like a middle point between high and low for like this?
Not for secondary school.
Let's write this one.
No. In general, they don't conduct electricity.
See what in general?
No need.
Okay. Then why the on top one need?
Oh, because on top one needs you to learn the exceptions sooner or later.
How soon?
You're talking about 4-5 months. That's it.
That's pretty soon.
Yeah. Solubility in water, in
Yes.
general, no.
Oh, so if electricity can be conducted, there's no and no. Melting. Oh, MP, BP, and density is the same. Then electrical conductivity and solubility in water is also the same. For like everything.
So tell me, Fujin, what's the last box? Since you're so smart. Can they dissolve in organic solvent like alcohol?
Get it feeling wrong? No.
Okay, Fujin said no.
Is that what you say? Why Qin so 算很?
I'm not too sure. But actually there's a reason for that, which you have to know. Why is it? Yes, because
It's jump from 51 to 49.
what?
I swear your battery went from 50.
Yeah, it did. It's quite scary.
It just jumps
Yeah. All these are very draining, no? All this.
You don't plug in your laptop,
Not yet.
Scare me
I think I'm going to plug in very soon. Oh, but let me write down this final thing. I hope you notice something. Covalent. Okay, let me use the word same.
What's the difference between covalent and covalent?
Yeah, the same. Simple covalent compounds can dissolve in
Whatever.
covalent. Okay, sorry, let me rephrase. In other covalent compounds. Fujin, can you add in this point? I didn't mention earlier, organic solvent are covalent compounds. That is the key. That is why simple covalent molecules can dissolve inside organic solvents.
Kind of makes sense.
Yeah, it does. Okay, but anyway, let's go on. But there are of course exceptions, but no need to know for secondary school. Now, Fujin, what were you asking me just now? Yeah, you want to know?
I forgot. What did I ask?
Yeah, what do you ask?
What did I ask?
Okay, come, important. Let's go back to ionic compounds. How many ionic compounds are there? Lots and lots.
Thousands.
More than that. But anyway,
Millions.
for secondary school, only a few. Okay. First thing, I think I've written this many times. Ionic compounds is made out of two things, which is made out of cation
And anions.
Yes. bonded to anions.
I thought that we went down.
No, of course, what's the bonding called?
Fixed. Hi.
Ionic compounds contain what kind of bond?
Hi.
Ionic compounds contain what kind of bonds?
Solid.
What do you write?
Solid.
Bonds? Bonds?
Sorry. Giant lattice structure.
That's the structure.
Yeah.
I'm referring to the bonds.
Yeah, bonds. Giant lattice bond.
Oh no, you're in big trouble. Look at what I wrote here. What did I write?
Ionic bonds.
Yeah.
Then what do you write? Giant lattice bond.
No, I didn't.
Oh, sure. This is a structure. This is the bond.
Yeah.
No question.
No cursing, huh?
No question, Dave.
What?
No question, Dave.
No correction tape in this center. I don't think so, unless some student has left it. No, you're out of luck.
Damn it. Since Jamie can't over give correction, Dave.
Cannot.
Ah. Now let's write this over. Giant. Jeez, I write on me. Sure. I can safely bet that Jin that's not gonna go on Monday. He confirm it's not gonna go on Monday.
Okay.
Confirm.
No, I have confidence in him.
He's like, I got pussy out.
He's going to ignore you.
Oi.
Okay, this part is important. Yeah. What do you need to know? Okay, go.
Let me throw the plastic away.
No, I haven't even drunk it at all.
The plastic!
Oh, plastic.
Let me throw.
I think to throw the whole thing away. Thank you. Okay, Tingjie, this is important for you too. There are lots of cations and anions, but there are some standard ones you need to know. Okay, let's look at cations first. Huh? Now, obviously, cations must be a metal ion. And I think we are pretty familiar by now. They are positively charged. Anions are, of course, non-metal. And of course, the reverse in terms of charge. Now, what are the kinds you need to know for O levels? Okay, I'm going to write down. This one you really need to remember by heart. Okay, look at group 1. Okay, Jinjie, I hope you have your periodic table with you. Now, look at group 1. You have lithium. So group 1 will form 1+. You have sodium. You have potassium. Okay, the rest may or may not come up for you. Okay, group 2. Beryllium, possible, it has come up before.
You always lock sound, I want to scare you. Every time I slowly, I want to scare you. I always see me coming.
Yeah, too big size to be
What the
to be ignored, right?
What the hell?
Hey, write down here. These are important. Ionic compounds. What are the cations and anions you need to know? Super important.
Bounce.
Okay, let's go on with group 2. Magnesium 2 plus, calcium 2 plus.
Positive what?
Positive charge. Now, which strontium occasionally comes out?
I think what strontium?
Hey, but you got periodic table. Look at group 2.
Oh, number 28.
Yeah, so notice all of them can become 2 plus cations, 2 plus, because they're in group 2. And barium, which come up more often.
I'm not right all that. That's too much to write.
That's fine. Radium is very rare, hardly comes up.
Does radiation have radiation?
Yes, possible.
Say anyway, the word art.
Group 3. Group 3, there's only one that comes up often. Which one? This one you have to write down. Aluminium comes out all the time. All the time.
What's Al3 plus?
Aluminium cation. Oh, actually, I'm using the old periodic table, so it's group 13 now.
Bruh. What's your group 30? Oh, because of this one, right?
Yeah.
1, 2, 3, 4, 5, 6, 7. Why don't you bring out a new table?
Soon.
Give me this. I'll keep this.
Because now you're the only 2 using it. So
Really?
all the Sec 4s are still using this.
Then the Jinjia's cousin.
I don't know. But they don't need to use this much of the periodic table yet.
Sec 2 eh?
Yeah, not much. Soon, I will print out soon. Okay, group 14.
Sec 2 don't use much of periodic table.
A bit, not that much.
I swear, Sec 2 been using periodic table all my life.
Are you sure? You hardly even go to school in Sec 2.
Exactly, that's why I'm even clear. I use quite a lot of periodic table.
Okay, okay, group
Maybe I'm
14.
remembering it wrongly.
Yeah, probably you did. Now, the one that is going to come up will be lead, confirm one. But lead doesn't become 4 plus, it becomes 2 plus.
EB.
Again, guys, I'm not writing all this for fun. Make sure you remember.
14, BB, 2 plus.
Now, then a few others very special ones that will come out. Okay, iron.
Get the order. Get the doctor. The fever, before OBS, I get fever. What the shit am I supposed to do?
Fujin, iron will surely come out 100%. You know why? Iron can form 2 kinds of ions.
No, I want to pay attention. I'm so bored.
Continue, okay. Come on, focus. A1.
Fe2 plus, Fe2 plus.
Okay? Oh, I'm serious. They ask about this all the time. Fe2 and Fe3. So they sometimes call it iron 2. And this is
Like
iron
copper
2. Yep. And as Fuji mentioned, copper is definitely coming out too. But copper is all.
Copper sulfate is CS, right? It's copper sulfate CuS.
CuSO4. Okay, so this is called copper 2. Okay, by the way, for lead, can you add in? It's normally called lead 2 as well. Anything else? Zinc? Okay, zinc. Zinc will surely come up. Okay. Try to write down 100% coming out on zinc.
I'm waiting for the anion.
Oh,
I have more space with you.
I would say out of this whole list here, the only one that probably that has a lower chance of coming up is this one, strontium. This only comes up once in a long, long while. But the rest, I can tell you 100% they're coming up.
What does PBO
Lab PB.
Not even in this.
Yeah, it is. Look at group 4 or group 14.
3, 4. Oh yeah, I didn't know that existed in this.
Okay, not too bad, right? Only about 10 cat ions here. Not too bad. Oh yeah. Actually, there's one more. Where guys, write down. There's one more I missed. Silver. Okay, silver will form silver plus. I would say all this 100% coming out, except for strontium. Anions, which is what Fujin has been waiting for. Anions, you have a few. Okay, let's look at group 17.
No
sharing.
I think plugging at top is very at 30 plus.
Yes, good idea. Yeah, Fujin, continue. Ions is a bit more complicated because you have to remember their special names.
Team 姐还有 weed，
My what?
还有 weed，
What?
a weed.
Weep.
Yes.
Yes.
That's such a disappointment.
Okay, come. So, group 17, look at the whole list, start with fluorine. So I have, all right.
F minus.
Yes, because they can lose one electron, only one electron. Cl minus, chloride. Hey, guys, take note of the name. It's no longer chlorine or fluorine. It's fluoride and chloride. Bromide. Iodide. So there's group 7. 17, I mean. Look at group 16. Here, group 16, oxygen can form O2 minus. And it's quite easy to deduce the name, oxide. And the other one is S2 minus, group 16. And what's the name?
Sulfate.
It's still sulfide. Okay, the rest don't bother. Group 15, only one. Notice the charge now becomes 3 minus, So this is nitrite. Group 14, only one of interest. And now the charge becomes 4 minus. All right, Jingjie, what's the name of C4 minus?
Of what?
C4 minus. What's the name?
Carbon.
Carbide. All these anions end with IDE. Serious, I hope you guys noticed that by now.
Okay.
Okay. IDE.
Just so hot.
Yeah, it is. But for anions, it's a bit complicated. There are other kinds that are not single elements. Okay. This one. Again, 100% coming out.
I don't know everything in it.
Okay, some more. This one, very funny
No
one.
more space already. Literally got no more space.
You need more thin paper?
No, not now, not now.
I give you
Maybe tomorrow.
A1, A1,
No,
A2,
no. A4.
A4.
No, I'm kidding. No, no,
You
no,
want?
no. I
No, this is polyatomic, very special. SO4 2 minus.
Which group?
This is not in any group because this combines sulfur and oxygen.
4.
This is called sulfate. Okay, I stress it ends with 8 ATE. Again, I'm not writing this for fun. Confirm coming up. Next one. NO3 minus. The name? Nitrate. Again, I hope you notice it ends with ATE as well. The other one that will come out, CO3 2 minus. No surprise here, it's called carbonate. ATE2. Can And there's one very special one. Okay. And this one is OH minus. This does not end with I or it. It ends, actually it ends with I. Now that I think about it. This is called hydroxide.
OH
minus. And I can confirm.
How about peroxide?
Oh, you want to know? Oh, okay, long. He asked for a special one, peroxide, which may come out, even though it's not common. So peroxide is very special. O minus.
Huh? That's an oxygen minus. Peroxide.
Hold on, no. No, hold on. It doesn't come out in this manner. It's very special. O2 minus peroxide. Okay, one more. That may not come out. H minus, so special.
Hydroxide.
No, hydroxide. Hydroxide is very out there.
Oh yeah. Nó got any quota here. Too bad. Of course, I bet I'm back in sale.
One more important one.
Okay,
Okay, this one is super important. 110% coming up. Okay, this is hydrogen ion.
What group?
Well, hydrogen is considered group 1.
Hydrogen.
H plus. H plus confirm coming up. Yes, go.
Oh.
Now, Jingxie, I think for you, you've got to be careful when you see hydrogen. Look at this too. Okay, so be very careful. Is it H plus or H minus? Right, they are different. Their names are different too. H plus is simply called hydrogen ion. H minus is hydride. Okay, now next one. Jingxie, tell you what, go back to this page. Okay, now for you, you need to know everything here. Because for Fujin, he only needs to know this one and this one. All right, for Fujin, only row number 1 and number 2. But for you, you need to know all 4 rows. Okay, so let's continue. Number 3. Jingjie, remember this. 1, 2, 3, 4. Because for this row number 3, you only have 4 examples. Only 4. You only need to know 4. At least that's for O levels. Try your best to remember them. Of course, you notice they're in group 4. Silicon and carbon in group 4. Okay, so silicon and carbon are in group 4 or group 14. Okay, structure. Write this down. Giant lattice structure. For these 4 guys, 1, 2, 3, 4, they exist in giant lattice structure. Room temperature, what do you think? Solid, liquid, or gas?
Solid.
Good. They are giant lattice structure, very difficult to break. Melting point, boiling point, since they are solids, well, as I said, they're difficult to break. Confirm high. Density, high. But next one you better take note. Oh, actually no need to take note. You should know the answer. Okay. In this case, no electrical conductivity except.
I thought graphite can.
Yeah, that's the exception.
Oh.
Which you need to know. And also explain, which I haven't explained yet. And silicon as well, but silicon you don't have to know the details. That one don't bother. Soluble, no. Okay. Solubility, organic solvent, no. Okay, because their structure is so big, they can't really dissolve well. Any questions, Jingqian?
No.
No. Okay, later I'll just go through some of the explanation, but let's finish off with matter. Okay, matter means all matters, of course. And that includes alloys. Qingqie, can you remember some examples of alloys? Alloys?
No.
Oh no. Okay, you have to remember a few.
Alloys. Okay, never mind.
Okay, brass is a common example.
Oh.
But it's still a metal, even though it's not an element, it's not a pure element. Brass is made out of copper and zinc. Okay, the other one you have to know is steel. Okay, steel is iron plus carbon. Okay, one more, stainless steel. Stainless steel, you add something to the steel. Iron plus chromium plus carbon. So these are examples of alloys. Okay, of course, any questions, just voice out. Metals, what kind of structure? You know they're metallic bonds. I mean, I haven't explained what is metallic bond, but that can come in later. What kind of structure do you think metals have?
Strong.
Yeah, strong. And guess what? It's also giant lattice structure. All right, metals, solid in general. High melting point, boiling point. High density. Electrical conductivity, yes, of course. Solubility in water, no. Organic solvent, no.
Can you zoom out a bit?
Okay, sure.
I'll screenshot this.
Can?
Yeah. Okay.
Okay. But let me touch on a few things. Graphite. Let me see. Hold on, I don't have the pictures here. It'd be hard to show you without the pictures. Okay, one more thing. Now, take note. You notice giant lattice, and giant lattice. Okay, but for you also have to differentiate. And so there are three kinds. And take note, there are three kinds of giant lattice structure which you have to differentiate. One is giant ionic. Number two, giant covalent. And number three, giant metallic. Okay, they are different. Okay, so I want you to keep this in mind. There are three kinds of giant lattice structures. Now, of course, I think it's kind of obvious. This is for ionic compounds. This is for covalent compounds. Okay, and the last one will be for metals. Can?
Okay.
Okay, let's go to this important concept here. Very important. Now, remember ionic compounds is made out of cation ion and anion. So let's say I tell you this lithium. Oh, not lithium. So let's say lithium.
I hear the third right.
Yeah, great.
I have bad diarrhea, bro.
So have you finished releasing your stuff?
Yes.
Great. Okay, lithium chloride.
Yeah, lithium chloride.
First question, is it an ionic compound?
Yes.
Yeah, of course. Metal and non-metal. Now, what's the cation?
Chloride.
Chloride is negative.
Then lithium.
Yep. So it's made out of lithium plus and Cl minus. Hey, Fujin, this applies to you, no? So you better listen as well.
I am listening.
And therefore, because it's one positive balances one negative, it's 1:1. And therefore, the formula is LiCl. Okay? Fujin, come. Serious, this is important. This will apply for the rest of your secondary school. But what if I have this magnesium chloride?
They are both metals.
What?
Except chloride. Metal is a magnesium is a non-metal. Magnesium is a metal. Chloride is a non-metal.
Yeah, you better be sure.
How many start words?
Magnesium chloride. What are the ions in magnesium chloride? It's an ionic compound, right?
Yeah.
What's the magnesium ion?
N.
G.
2 plus.
Yeah, because
So
you
what's it 2?
there we wrote out just now. Because it's in group 2.
Oh yeah.
Group
I need
2.
my this one.
Because chloride.
It's 12 though.
Oh, that doesn't matter. What matters is it's in group 2.
Oh.
So it's 2 plus. But chloride is in group 17, so it forms Cl minus.
If it's in group 14, then it'll be 14 plus, right?
No, 14 means 4 minus. 14 is quite special.
I mean, group 14.
Come, let's look at what we have written. Where's group 14? This big list here?
Over there.
Oh, group 14, I only see Pb2 plus.
Oh.
Yeah, it's quite special.
Group 13 also.
Group 13, Al3
Minus
plus.
10, take away the 10.
Yeah. Fujin, come. Magnesium is made out of these 2 ions. Fujin. Magnesium is there.
Yeah.
So, what's the formula of magnesium chloride?
Mg2 plus Cl. MgCl2.
Wow, fantastic. I hope you heard that, Jingjie. Notice 2
Yeah.
plus, you have to balance with 1 minus. So therefore, take the LCM.
MgCl.
This is times 1, this is times 2. So therefore, it's MgCl2. Okay, next one. How about aluminum chloride? Fujin, what's the formula? Aluminum chloride.
AlCl.
Mm,
ACl.
ions, Al3 plus.
Alright, Cl2.
Cl minus
2.
Hey, 3 plus. How do you balance 3 plus and 1 minus?
Nothing. Unbalanceable.
No, what's the LCM? Lowest?
3.
Yeah, 3. So
AlCl3.
yeah.
No,
So
what's the name? What was the words? The words disappeared.
oh, it's okay. You better know this.
Yes, I know already.
You know. I ask you then, which you can answer.
Okay.
Jing Jie, okay.
I locked the door.
Okay, can sit down. Jing Jie, any questions? No.
No.
Guys, class is over.
Let's give you a difficult one. Hey, come.
Watching.
How about this? Let's say I give you magnesium carbonate.
Magnesium 2 plus.
Good.
Or carbonate. Carbon is six group 1, 2, 3, 4, 14.
You have to look at your list. You can't look at this anymore. Because carbonate is not carbon by itself. What are the ions?
Carbide? No. CO32.
CO32 minus.
Yeah, minus. CO32 minus.
Can the 2 plus balance the 2
Yes,
minus?
can.
Can, right? So therefore,
MgCO3.
that is all. This is the formula.
Yes.
Yes. How about let's
So
give you.
easy.
Oh, okay, give you this one. Sodium carbonate.
Sodium is Na.
Na. Where's my plus?
Sodium.
The ion is
1.
okay. 1
Na
plus.
plus 1.
Carbonate.
Carbonate is CO3 2 minus.
Okay. What's the formula?
NaCO32. Plus. Minus. NaCO32 minus.
No. 1 plus. How are you going to balance 1 plus with 2 minus?
Na1 CO3. I don't know what.
Oh, no. Okay, sit down. This one you have to times 2.
Why times 2?
So that you can get 2 plus to balance the 2 minus. What's the LCM is 2, right?
Yeah.
So what's the formula now? It's
CO32. Na2.
Yes, better know this.
Okay.
Okay? No. Let's give you another one. How about difficult one?
My balls.
Aluminium sulfate. Aluminium sulfate?
Al.
What's the ion? Aluminum.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 group 13. So it's Al3 plus.
Good. Sulfate.
Sulfate. SO4 2 minus.
Okay, excellent. What's the LCM?
It cannot balance.
Yeah, cannot.
So must 3 times 2, 2 times 3.
Good.
Al6, SO4 6.
No, you just need to times 2. This one times 3. So it becomes Al2. SO4, but the 4 is a hindrance, so make sure you bracket it. 3.
Oh.
Hey, seriously, you better know how to write this. Al2, SO4, 3. Notice the bracket.
Yes.
Okay? Now, one more. Of course, Jing try to follow. Let's say I have, how about this aluminum nitrate? What's the formula for aluminum nitrate? Aluminum is always Al3 plus. Nitrate?
Nitrate, NO3 minus.
Good. So together, how to balance each other?
Times.
Which one times?
NO3.
Times what?
3.
Great.
So it's AL3.
No.
ALNO3.
Yes, but make sure you enclose the bracket NO3 with a 3 outside. Yeah, Huijian.
Yeah.
Xingjie, okay.
Lesson's over, guys.
Not yet.
Over is it?
Okay, quick reminder. Do a final one. Dot cross diagram.
I hate that shit.
It's going to come up.
这不是啊。
Come, guys, draw the dot cross diagram for this aluminum chloride.
No.
Look at it, AlCl3. Fujin, how many electrons does aluminum have?
That's for
Mhm.
aluminium. 13.
Great. So make sure you draw aluminum first. How many shells does it have?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18. 1, 2, 3, 4 shells.
What row is it in? First row, second row, third row. Third row means 3 shells.
Oh, close enough.
1, 2,
3, 4, 5, 6, 7, 8,
okay, aluminum. Then you draw for chloride. Kang Fujin, chloride. Chlorine, how many shells? Remember, this is called dot cross diagram. So dot and cross. Fujin, how many electrons does chlorine have?
Super brilliant.
I think you're in trouble. You're supposed to have 17.
17.
If you remember your stuff. So you need to draw 17 crosses.
Christianity to the maximum.
But don't forget, this is going to be transferred here. Okay? And this is going to be transferred to another chlorine. And this is going to be transferred to another chlorine. Okay? So what happens is, now the outer shell is gone. So in its place, I have a cross here. I have a dot here. Here.
I don't put that right. He'll give them.
But because aluminum has lost 3 electrons, it is now 3 plus. And let me stress, you need to have the square brackets. What else? Chlorine has gained 1 electron. So it's 1 minus with the square bracket. But remember, I did say that 3 electrons went to 3 chlorine atoms, so I need to have a 3 here.
How to off this? I turn it off.
Okay, sure. You can still see by the way.
Yeah.
Hey, you need to practice now. Okay, so that's how you draw the dot cross diagram for ionic compounds. Okay, that's about it for today. Questions?
No.
Yep.
So retreat students now, like,
Yeah. Wow, fun.
okay. Be able to handle those 2 boys while really they're very noisy. Then
Yeah.
Oh.
Yeah, that's you. Okay, yep, guys, that's all for today.
Thank you, audience. I thought I didn't know my fault.
Huh?
You never bring my report.
You ah.
I'll take next week.
Next week ah. You better. Oh, no, I'll shove it to you tomorrow.
You can't find it tomorrow. Oh wait, you can.
Of course I can.
Shit.
Okay, man. That's all.
I think yeah. See you tomorrow.
Bye.
Bye.